Hello everyone, welcome back to Diksha Karnataka YouTube channel. I am really sorry for slight delay because there was some issue with the security. As you know, today is Sunday, so our security was briefly not available. Yes, I am here live at 10:30. It was supposed to be at 10 a.m. and please let me know if you can hear me or not. Right. So, so today what I am going to do, I am going to discuss, as I discussed yesterday as well. I am going to just a second. So today I am basically going to discuss the important questions, mainly important MCQs as well as your numerical questions that might come from your for your unit test, right? So let's get ready, and here you will be answering the questions, not me. I am in case it requires, I will explain definitely, but try to answer them first on your own so that you will be able to understand whether you understand the questions or not. So let's start with the session today. First question is here: the electric field at a distance small r from a infinitely long straight uniformly charged wire. Okay, so electric field at a distance small r from a uniformly long straight uniformly charged wire is inversely proportional to r. Option B, inversely proportional to cube of r, inversely proportional to square of r, independent of r. So try to answer this question. Okay. Option C, Rajini is saying option C, Rohit is saying option C, JOP is saying option A. Sir, are you going to do PYQs first board test paper? Sufia Banu, not exactly the board board paper, but I will definitely solve all the important questions that is being this type of questions were asked in the previous year board questions as well, and these MCQs are also collected, some from your previous year questions, some from your model paper, some from your question bank. So all the questions here are important questions. Okay, some questions are taken from some reference books as well. So this is a mix of all types of questions that you can expect. Numericals I am going to solve. Okay, that those are very important numericals. So now let's see. Most of you are saying option C except JOP and Mahin. Everyone is saying option C. Option C is incorrect option. This is not correct option. Okay, this is not correct. Infinitely long straight wire electric field was given by 1 by 2 pi epsilon naught lambda by r. If you remember, this was the expression, right? I generally try to write it as 4 pi and 2 lambda over here. So whatever you are comfortable with. So this is the expression for electric field due to an infinitely long straight wire. So electric field is directly proportional to 1 upon r, not 1 upon r square. If it is a point charge, it will be a square of r, but it is an infinitely long straight wire, so it will be inversely proportional to only r, not 1 by r square. So be careful when you answer these questions. These are tricky MCQ questions. Most students, even if they are seemingly simple and easy, you make mistakes in them. So that's why I am going to practice MCQs with you. So next question, very important question: which one of the following charges is not possible? Which of the following charges is not possible? So let's see. Yes, option A was Abhishek, just follow this lecture, you will at least score 5 to 7 to 10 marks easily. Okay, and then there was one more lecture where I have discussed important questions. Yesterday it was released, 5-6 minutes video. You can just go through them, you will have an idea what type of questions you can expect. Now if you want a detailed solution of that, for that you have to watch my long 2 hour 30 minutes video where I have discussed solution for all the important questions as well. So based on your time availability, you can either watch that 2.5 hour video, or if you don't have time, you want to study from your textbook or from your guidebook, you can go through the quick revision video that was uploaded yesterday. You can check that out, where I have discussed all the important questions. If you watch and solve those questions, definitely you will score very well in the upcoming exam, right? So now question option A, C, where it is said not possible, not possible. So be careful what you are answering over here. Nagraja is saying option C, Khalid option A, and okay. So now if you see that this is the charge of one single electron, this is the charge of one single electron. Now quantization principle says that charges can be integer multiple of this smallest value. Integer multiple means what? It can be E, it can be 2E, it can be 3E, it can be 4E, but it cannot be 3.5E. 3.5E is not possible. 3.5E is not possible. So if you see that this is 1.6, this is 3.2, which is exactly double, so 2E, right? If you see this one 5.6, 5.6 is actually not 3 times, not 4 times, it is 3.5 times. Okay, this one is 4 times. Sorry, I just marked it. So this one is 4 times. So this is E, this is 2E, this is 4E. These all are possible because they are integers. 1, 2, 4, they are integers. But here this is 3.5E. 3.5 is not an integer. It's a decimal number, right? So 3.5 is not possible. So this is the correct answer. This is not possible. Even though the question looks simple, question looks easy, the trick is that you have to find the integer multiple and see this charge is not possible because this is not an integer multiple of the smallest possible value. Anything smaller than that is obviously not possible, and anything between two integer values is also not possible. That's why this one is not possible. Now next question, again another easy question. This one is easy question. The electrostatic force between two charges in vacuum is given by F equals to K Q1 Q2 by R square, where K is 9 into 10 to the power of 9 Newton meter square per coulomb square, 9 into 10 to the power of 9 Newton coulomb square per meter square, 9 into 10 to the power of minus 9 Newton meter square per coulomb square, 9 into 10 to the power of 9 Newton. Be very careful, answer everyone knows. Sir, can you please provide answers for the questions which you have discussed yesterday's video? Abhishek, answers are discussed in the long lecture and the PDF is available in the Google Drive. We have shared the link yesterday also. If you have not yet joined the WhatsApp channel, don't forget to join the WhatsApp channel. Link is given in the description of this live video. So join there and find the Google Drive link. It is given as a form of answer sheet as well. You can find the questions and their respective answers. So don't worry about that as well. Sir, from your yesterday's and today's video, can I get 30 marks? Rohit, yes. If you have solved those questions, definitely you can score 30 plus. Now let's see. Option, some is saying option C, some is saying option A, and Padma is saying option A. So be careful, as I said, K is 9 into 10 to the power of 9. The magnitude is okay. Magnitude everyone knows, it will be 10 to the power of 9, not minus 9. 10 to the power of 9. K is 9 into 10 to the power of 9, and most of the cases this is sufficient to answer, except for this question. Except for this question. So why, how to find it? If you want to do that, you have to see that the left hand side is force. So ultimately after you put the unit, it should be force also. Okay, and one more thing is that if you see that all the options, only 2 units are same. Only 2 units are same. This is a way to guess. Even if you don't know, the correct answer. This is a way to guess. If you see that these two units are same, that means this must be the correct unit. This must be the correct unit, and this value is the correct value. This value is very common. We are using it for solving numerical questions. So this is the correct answer, option A. Those who have mentioned option C is not correct. Any other options are not correct. Okay. Option A, yes, option A. Now next question, the direction of electric field vector at a point on the equatorial line of the dipole is. So direction, they are talking about what? They are talking about direction of the electric field vector, okay, at a point on the equatorial line of the dipole. Equatorial line means what? So this is the dipole, okay. So this is the axis and this is the equatorial plane, okay. So equatorial plane are, so dipole moment, so suppose this is negative q, this is plus q. So what is the direction of dipole moment? Dipole moment is always from negative to positive. Dipole moment is always from negative to positive. On the axial line, dipole moment is in the same direction. Dipole moment is in the same direction. Dipole moment and electric field vector, they are in the same direction. That's why their expression is positive. In the so now let's see the options. In the same direction of the dipole moment, in the opposite direction of the dipole moment, towards negative charge, away from the positive charge, right? In the opposite direction of the dipole moment, yes, yes, yes. Nagaraja, Padma, Rehan, no, not option D, not option D, it is opposite direction. It is opposite direction to the dipole moment. Dipole moment for equatorial plane, the electric field is in the opposite direction of the dipole moment. Always remember that on equatorial plane, dipole moment, P vector and electric field vector on the equatorial plane, they are in the opposite direction. That's why their expression is negative, whereas for axial case, it is in the same direction. That's why they are positive, okay. So equatorial plane and dipole moment, they are in the opposite direction, and axial case, they are in the same direction. Same direction means arrows will be in the same direction, right. Option B is correct. Now next question, name the physical quantity which has the dimensional formula LTA, okay. LTA, what is the dimensional formula of LTA? Dipole moment, capacitance, line charge density, charge. Tell me the answer. B, C, A, B, C, A. So lot of questions, lot of options, A, B, C, A, except D. Everyone is answering either A or B or C or D. So let's see what is LTA. Okay, let's analysis that. L is what? L is length, okay, no doubt about it. Now what is TA? What is T into A? That is what our target is. So what is A? A is current. Current means what? So T is what? T is time, right? And what is A? A is current. So what is the formula for current? Current is charge per unit time. So it will be charge divided by time. So if you cancel that, it is basically dimension of charge. So TA is basically dimension of charge and L is dimension of length. Now which quantity among the following has a length into charge formula? So capacitance Q is equal to CV. So there is no length involved in there. Charge is there, but no length involved there. Line charge density, in this case line charge density is charge divided by length. Line charge density is charge divided by length, but if you see here, it is charge multiplied by length. So this is not correct. This is a good guess but not correct. Option C is good guess but not correct because it is charge divided by length not multiplied. So, only case where we multiply charge and length is dipole moment. If you remember, P is equal to Q into 2A. What is this A? What is this A? This A is nothing but length, distance between the charges. So, this is plus Q suppose, this is minus Q suppose, this is 2A. So, dipole moment is basically given by charge, any one of the charges multiplied by the distance between them, which is a length. So, charge into length comes only for dipole moment. So, this is the correct answer. If the same question was asked with the dimension L to the power of minus 1 T into A, then it would have been line charge density. Line charge density, L is division, L is in the division, that means L to the power of minus 1. Okay. Capacitance is Q is equal to CV or C is equal to Q by V. Okay. So, the dimension is slightly complicated than this. So, that is why this is not the answer. Okay. Now, let us move on to the next question. Dash placed in an electric field experiences a force in the direction opposite to the electric field. An electron, a positive charge, a neutron, a proton. Okay, which of the following experiences a force opposite to that of the electric field? Option A, option B, option A, option B. Let us see. In this case, option A and option B people are debating. So, let us see what is electric field. Electric field is basically if you leave a unit positive charge, if you leave a unit positive test charge, the direction it takes is the direction of the electric field. The direction of electric field is defined by the path covered or path traversed by an positive charge, right. So, if you leave a unit any positive charge, that is a positive charge or a proton, both are positive charges. So, if you leave a positive charge in the electric field, both of them will move in the direction of electric field. Okay. Proton and positive charge both will move in the direction of electric field, not in the opposite direction. But if you leave an electron, then it will move in the opposite direction of the electric field, because it is a negative charge. Electron is a negative charge. Any negative charge will always move in the opposite direction of the electric field. Positive charges will move in the direction of electric field. Okay, and the force experienced by them is equal to Q into E. This is the expression for force. This is the direction of motion, right. So, only electron will experience a force in the direction opposite to that of the electric field. Rest, a positive charge and proton will experience force in the direction of electric field. Neutron is neutral, it will not experience any force because Q is 0 for a neutron. Okay. Now, question number 7. When a free electric dipole placed in a non-uniform electric field, the dipole will experience both force and torque, only force but not torque, only torque but no force, neither torque nor force. So, non-uniform electric field. Electron is placed in a dipole is placed in a non-uniform electric field. What is the meaning of non-uniform electric field? Non-uniform electric field means electric field is not constant throughout the place. Okay. So, for example, this is an example of non-uniform electric field. Okay. So, here the electric field is strong, and as you are moving, here it is weak. So, this is an example of non-uniform electric field. The non-uniform electric field can be drawn like this. If they are used, generally if they are parallel lines, that means electric field is uniform. This is uniform. Whereas, if you draw if they are converging or diverging from some point, that means they are non-uniform. Now, if you place an electric dipole, okay, what will happen to it? Will it experience any force, or it will only experience torque? We know that if we place a dipole in an uniform electric field, it experiences only torque. Okay. We have also calculated the expression for the torque, which is very important. So, now let us see what you are answering for this question. Both torque and force, Padma is saying, Puneet is saying option A, option A, option A. So, both force and torque. So, if you see that in terms of strong and weak field, okay, the side which is strong, which will also attract the charges more and repel the charges more. So, there will be a force based on the strength of the electric field, and torque will always be there. If you place a dipole in the electric field, it will always experience a torque. Torque is always there, but if the field is uniform, no force. If the field is not uniform, there will be a force as well. So, both force and the torque. So, option A is correct. So, Padma, yes, Padma, Puneet, Khalid, all are correct. Puneet is saying, sir, I am from Diksha offline Tumkur. Hi Puneet, welcome to YouTube channel. If you have not subscribed to our YouTube channel, definitely subscribe to it and also share it with your friends so that they can also join our lecture. Now, question number 8. Electrostatic field lines can never form closed loops. This is due to, so electric field lines, we know that. So, suppose this is a positive charge, electric field can generate from positive charge and travel towards infinity, and if there is a negative charge, what happens, that all the electric field lines converge towards the negative charge, they all jump here, right. So, they do not form a closed loop. What is the meaning of closed loop? Closed loop means it starts, suppose there is a positive, it starts from positive, and if somehow it ends at positive, then it is called a closed loop, but electric field do not follow this. Okay. Later on in the magnetic field case, we will see they form closed loops, but not the electric field. Why? What are the reason behind that? Conservation of charges, conservation of momentum, quantization of electric charges, conservative nature of electrostatic field. So, let us see what is the reason behind it. Who can answer this question? Whoever answer, he is the boss. He is the boss of today's. Rohit, C sir, last question. Let us see. Not C, only torque but no force. No, no, no. It will experience force also. I explained that. Because the electric field is not uniform, it will experience force as well. Okay, because suppose this is strong electric field, so this charge will experience more force. Okay, suppose this is negative, this is positive, this will experience less force. So, there will be a net force acting in this direction. There will be a net force acting in this direction, and there will be a force acting on this system as well. Okay. So, it will experience force as well as torque, not only the torque. Torque will always be there because there are some forces acting on this charge as well, right. So, both the charges are experiencing forces. So, that is why torque will be there, but there will be force as well. Now, this is the $1,000,000 question. Okay. Yes, most of you are answering it correct. Sanjana, Padma, Nisha, Rupa, okay. Sanjana, another Sania, okay, Sania. Everyone is saying option D. Yes, conservative nature of the electrostatic field, because if you do some work on the charge, okay, and if you do external work on the charge, if you release that charge, you get back that work that is done by you. So, suppose there is a negative charge, this is a positive charge, this is the negative charge. You did some work to bring it over here. Okay, you do some work, and once you release it, it again goes back to here and giving you back the exact amount of work that you have done on this charge. This is only possible if the field is conservative. If the field is not conservative, loop is possible. Okay. Magnetic field, there is a particular case, magnetic field, even though magnetic field is also conservative, but there are some caveat to that, there are some internal mechanism is there, that is why it is closed loop. But electrostatic field lines are not forming closed loop mainly because it is a completely conservative field. Next question, this is also very important. Try to answer this question. Let us see who can answer. I am giving you 10 seconds. 4 charges are placed at the corners of a square PQRS. So we have PQRS, it is shown over here. The direction of the resultant electric field at the intersection of the diagonal. So what is the direction of electric field at the intersection of the diagonal? Okay. So so towards P. So the options are towards P, towards Q, towards R, towards S. So these are the 4 options. One of the option is correct, rest of them are incorrect. So let's see. 4 charges are placed at the corners of a square PQRS as shown in the figure. The direction of the resultant electric field, intersection of the diagonal. Now what is given over here? If you see that at P we have 2 nanocoulomb, at Q we have another 2 nanocoulomb, at R we have minus 2 nanocoulomb, and at S we have another plus 2 nanocoulomb. So 3 plus 2 nanocoulombs and 1 minus 2 nanocoulomb. Okay, so this is minus. Rest of them are positive. So now see, let's see who can answer this question. Okay. Option C, option C, option C. Most of you are saying option C. Let's see which of them, which answer is correct. Uday, Meghna, Tarun, Punit, Sanjana, Meghna, Tarun. Don't repeat. Once you answered, that is sufficient. I will take the answer. Okay. Now let's see. So here if you see that this is positive, this is positive. So there will be an electric field in this direction due to this charge, right? Electric field is always away due to positive charge, and this is also plus 2, same distance, equal distance. So electric field will there also, and they will cancel each other. They will cancel each other. Now if you see that this positive charge, there will be an electric field in this direction, okay, away from this positive charge. This is negative charge, so that there will be an electric field due to this charge towards it, right? So both the electric field for P and R, both will be towards R. So combined electric field will be towards R only. The electric field due to Q and S, they will cancel each other, but P and R, they will add up, and it will be, the answer will be towards R. That is option C. Those all of you who have answered R is correct. Now next question. Easy question. The following figure shows the electric field around 2 charges. Okay, so there are 2 charges, Q1 and Q2. Now you have to answer that Q1 is positive and Q2 is negative. Q1 is negative and Q2 is positive. Both charges are positive, both charges are negative. Now let's see who can answer this question. Tarun, Nagaraj, Pratap, Lata, everyone is saying option C. Option C. Okay, let's see. So here you can see that the electric field lines are going out of the charges. So out of the charge means definitely this is a positive charge. Now if you see this charge also, the charge lines are again going outside. So field lines going out means again this is a positive charge. So both Q1 and Q2 must be positive. So option C is correct. Again, those who have answered option C, for example, Pratap, Tarun, Mahin, Memar, Rupa, Meghna, Rohini, everyone is correct. Rohit or Rohini, sorry. So everyone is correct. Now question number 11. Equal charges are given to two spheres of different radii. The potential will be. So here we have 2 spheres. One is bigger sphere, another one is small sphere. Same amount of charge is given. Now we have to say that the potential will be more on bigger sphere, more on smaller sphere, be equal on both spheres, depend on the nature of the materials of the sphere. So definitely one of the option is definitely, you can rule that out. So now let's see. Ganesh, Ganesh is saying option D. Interesting. Meghna, Rohit, MR, everyone is saying option C. Ganesh, only option D you can eliminate easily. So be careful. It does not depend on the material of the sphere. Okay, nature of the material. It is independent on that. There is only one thing that it depends. If you understand that, Pratap and Lata is saying option B. Okay, Rohini Kumbar is saying option A. Nagaraja is saying option. Nagaraja and Pratap, these two are saying B. Vishal Kashyap is saying B. Okay. C, C, A, C. Okay, let's see. So, if you remember the formula for electric potential on the surface of a sphere, we have done that. We have calculated it, right? So, electric potential is given by K, Q by R. On the surface of a sphere, the electric field is given by KQ by R. For electric field is KQ by R square, electric potential is KQ by R, right. So, if you remember this formula, higher the radius, smaller is the potential, smaller the radius, higher is the potential. So, this will be, this potential is definitely smaller than this potential. So, VR must be greater than V capital R. So, from here we can say that it will be more for smaller sphere than the bigger sphere. So, option B is correct. So, Pratap and Lata and one more student till I was checking has answered it correctly. Okay. Now, everyone is saying option B. Okay, Nagaraja and Pratap and Lata was answered correctly, I think. Okay. So, you have to be careful again. Some cases there is the solutions are not direct. You have to understand is using the formulas and then interpret the result. Okay, even though it looks like a no formula based question, actually it requires you to solve this through this formula. Okay, clear? Next question. Electric potential, we have 30 MCQs today. Okay, so try to answer them faster. The electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volts. The electric potential at the center of this shell, we have a shell. Okay, shell means remember egg. Okay, inside is empty egg, but without the everything inside it. Okay, so inside is empty, only the outer cover is there. Okay, like a football. Inside only air is present, outside there is a cover. So, it says that the radius is given 10 centimeter, okay, and the potential on the surface is 20 volts. So, what is the potential at the center? Now, let us see. Options are 0, 10 volt, 20 volt, 2 volt. Option A, option Uday is saying option C, Meghna Tarun is saying option A. Tejas is saying because radius is 0. Now, you have to understand one thing. Okay, electric potential inside a shell or sphere. Okay, conducting sphere or shell. It can be conducting sphere, it can be a shell. Electric potential inside the shell is constant. It is not 0. Electric field is 0, not potential. Electric field is 0, not the potential. Electric field can be 0, not potential. Okay, so electric field is constant up to the surface. After the surface, it decreases. So inside the shell or conducting sphere, electric potential is constant. Electric potential do vary if the sphere is dielectric sphere, but otherwise if it is a conducting sphere or a shell where charges reside only on the surface, okay, the electric potential inside is constant, it is not 0, and whatever the value is on the surface, same value will be at the center as well. So only I think one student I saw, Uday, answered it correctly. Later on Rohini and Meghna answered it with the hint. Khalid Shapure, welcome Khalid, you also answered it correctly. So this is the logic. You have to understand that electric potential inside a shell and conducting sphere is constant, whereas electric field is 0. So E is 0, but V is constant. Okay, electric field is 0, V is constant. Next, the electric field at a point which is very close to the surface of a charged conductor with the surface charge density sigma. So we have a charged conductor, it is not charge insulated, it is a conductor. Okay, what will be the electric field near to this charged conductor? What will be the electric field near to this charged conductor? E is equal to sigma by 2 epsilon naught, E is equal to sigma by epsilon naught, E is equal to 2 sigma naught by epsilon, E is equal to 2 sigma by epsilon naught. Meghna option B, MR Mohan Kumar option B, Rohit option B, Tarun option A, Tarun no, Tarun it will be option B. Okay, this one is for if it is a infinitely long sheet of paper, nothing to do with conductor. If it is a conductor, it will be sigma by epsilon naught. If it is an insulator and infinitely long, then it will be sigma by 2 epsilon naught. Okay, sigma by 2 epsilon naught is for non-conductors and infinitely long. Okay, so infinitely long insulating paper or just a normal charge sheet, it will be sigma by 2 epsilon naught. It is not conductor. If it is conductor, it will always be sigma by epsilon naught. Okay, be it infinite or be it very close to the surface, it will always be sigma by epsilon naught, because conductors have charges on both sides. So there will be one electric field here, another electric field will be here. So it will be sigma by epsilon naught, not sigma by 2 epsilon naught. Okay, clear? Now next question. The energy density between the plates of a charged capacitor is given by. So energy density between the plates, it is energy density, not the energy stored. So be careful, energy density between the plates of a charged capacitor is given by half CV square, half epsilon naught E square, half epsilon naught V square, half QV. Nagraj saying option A, Rohit option A, half CV square, Meghna option, Rohit option A, Keset Warrior is saying option A, MR Mohan Kumar option A, option A, option A, option A. So again, this was a trap, and again you fall for the trap. I already told you, this is not the total energy stored, this is total energy stored, this is total energy stored. Okay, the energy density is total energy stored divided by the volume of the capacitor. Total energy stored divided by the volume of the capacitor. Now if you put the value of C, if you put the value of the volume, this is not voltage by the way, this is volume. Okay, capital V. Okay, volume. So if you divide it, then you will get the energy density, which will come out to be half epsilon naught E square, half epsilon naught E square. Even though the derivation is not part of your syllabus, it is given in your NCERT textbook, you can go and check that out. Energy density is half epsilon naught E square, total energy stored is half CV square. Okay, this is total energy stored, total. It is density, this is density. Okay, so tomorrow is your exam and you have not yet prepared yet. Let's see the next question. The potential energy of an electric dipole placed in a uniform electric field is, this is easy question. Potential difference, potential of electric dipole placed in an uniform electric field is minus P dot E minus P cross E half C V square half epsilon naught E square. Now let's see. Sir, MTG objective Karnataka CT book is enough for KSET. Please tell me KSET aspirants. It is not enough, but it is a good book. Okay, it is a good book. Main thing you have to do, you have to finish your NCRT. That is first. Okay, they have MTG KSET book. They have given a good summary, but detailed theory explanations are not there. The detailed questions which is coming in your KSET exam is not there. So main thing is your NCRT textbook that you have to follow completely. Okay, MTG can be a reference book now, but it is not the entire book. You can practice from there, that is a good practice material, but your first book that you have to do is NCRT, second will be your reference book. Okay, let me have some water. Let's see, option A, option A, option A, yes, this is a scalar quantity. So most of you are saying option is correct. Teja, Tejas, Maheen, Yashwant, KSET warrior, no. It will be option A. Khalid, Meghna, KSET, Nagaraja, option B, no, not option B. So if you see that, it is a potential energy. Potential energy is a scalar quantity. Okay. Potential energy is a scalar quantity, and for a dipole placed in an electric field, the potential energy is minus P dot E. Okay, minus P dot E. It is P E cos theta. P cross E gives you the torque acting on the dipole, not the potential energy. Okay, and that is, there is no negative sign also for torque, but for potential there is a negative sign. So in the option C, if it was given P dot E, and option D, suppose it is given P cross E, then you need to be careful, and you have to be very careful that it is the correct answer, not this one. Okay. Now next question. A capacitance of capacitor is defined as C is equal to Q by V. A factor on which the capacitance of the capacitor depends on charge Q, geometry of the conductor, potential difference V, all of the above. Sufia, I have not seen Jeevith's KSET book. Jeevith's PU book is very good. So assuming that PU book is good, their KSET book should also be very good. I have seen MTG book, the 10 years PYQ book, and the NCRT textbook. Those are the main three books that I personally follow. Jeevith books, I will try and find it out if it is good or not. In future I will tell you if it is good. Okay, I have personally not seen that Jeevith publications book. There used to be one more book, Bosco, but Bosco's quality of recent is not super good. Its old version, when the syllabus was old, was good. Recent publications, what I have seen personally, the quality is not up to the mark. Okay, they have too much content which is not required. Some portions are deleted, but still they have kept in their book. That is my problem with them. If they edit and update the book, then maybe that is also a good book. Okay, let's see. Option B says Nagaraja, KSET warrior also saying option B. Tarun is saying all of the above. Rohini is saying all of the above. Now you have to remember that again this is a trap question. So capacitance, even though the formula for capacitance is Q by V, Q and V are not independent, they are related to each other, but capacitance is given by epsilon naught A by D. Capacitance is given by, they just tried to mislead you. Okay, so they just tried to mislead you by giving you a different formula. So this formula is okay, but capacitance depends only on the geometry. Okay, if you are using a fixed value capacitor, suppose 200 microfarad capacitor, okay, the capacitance value is fixed. If you change voltage, charge will change accordingly. The ratio of Q by V is constant. The ratio of Q by V is constant, and that constant is called capacitance, and that capacitance depends only on the geometry of the conductor. It does not depend on the charge and voltage, it is only depends on the geometry. Geometry means what? Geometry means area, geometry means difference between the plates, right? So what is the size of the capacitor, what is the distance between the plates, this is called geometry. Geometry means physical appearance, physical shape. Okay, so geometry of the conductor is only on which capacitance depends. It does not depends on voltage, it does not depend on charge, because their ratio is constant. Sir, start questions and answers. Questions answer I have already discussed. Only numericals I will solve after the MCQs are over. MCQs are important. You can score easy marks from MCQs, but most of you will make mistakes in the MCQ. Even after practicing this, many of you will make mistakes in the MCQ. I can guarantee that, and you will try. MCQ can change the marks from 25 to 35. That is the difference between practicing MCQ and not practicing MCQ. Students think that MCQs are easy, tumba easy, I will score out of out without practicing MCQs, and they do not practice MCQs. That's why in our channel we focus more on MCQs and numerical questions where students make mistakes. So potential energy of a capacitor is stored in the dash between the plates of the capacitor. Electric charges, electric field, magnetic field, current. Easy, obvious question if you study a little bit. Sir, I start studying from 7-8 hours per day. Can I score above 90% in boards? Because till now I have not started studying. Roshan, if you start now, you can score easily out of out, but you have to be serious. Every day you will say, I will study from tomorrow, study from tomorrow, study from tomorrow, and then you will see that tomorrow is your final board exam. Okay, and then you will cry. So if you want to start, stop wasting time, focus on your study, at least 7-8 hours full focused on the study, and after you study then you can take a break or not. I am not asking you to study continuously for 7-8 hours. You have colleges, you have some holidays in between as well, so take some time off. Obviously some relaxation of the mind is also required, but utilize your time efficiently. If you are in the college, listen to the lectures and try to understand whatever doubts you have. Ask the teachers that these are my doubts. If you still have some doubts, you can come to us. We will be conducting live classes from time to time, and that's how you can build up on your doubts, right? Electric field, yes, correct answer is electric field, option B. Sir, I am your old student. I got 98 in physics because of you. Thank you, sir. Dexter, thank you, Dexter. Last year paper was difficult and you got 98. That means you have prepared really well, and congratulations to you. And now this is the question. This is the question that I was waiting for. The formula, the following graph shows the variations of two physical quantities with the distance small r from the center of a uniformly charged spherical shell. Identify the graphs. Okay, so here we have the graphs for two spherical shells for two different quantities. One quantities are measured along y-axis, distances are measured along x-axis. Okay, so what are these two graphs? First graph shows the variation of E versus R. Second graph is V versus R. So first graph shows variation of V versus R. Second graph is E versus R. Both graphs shows the variation of V versus R. Both graphs shows the variation of E versus R. Now let's see. K-Set Warrior, MR Mohan Kumar is saying option A. Tejas Rohit is saying option B. Tarun option B. Rohit saying option C. Meghna is saying option A. So let's see. First of all, try to figure this out. I will give you hint. What is the meaning of this? What is the meaning of this? What is the meaning of this? Right? And what is the meaning of this? This graph starts from nowhere. Okay, something happened. Wet muddy. So this graph means something, and if you see that there is another thing over here, and it comes like this. So what is the difference between these two? Yes, it will be option B. So if you see that this represents constant value. So if the graph is like this, okay, this represents constant. This means constant. So only inside a spherical shell, only potential is constant, and this means this value is 0. This is 0. So electric field is 0 over here. Electric field is 0 over here. So that is the only reason. Okay, so electric field is 0 over here, whereas here this means V is constant. Inside the spherical shell up to the radius r, electric field is 0, but electric potential is not 0, it is constant. So this must be V versus R. V versus R. It is E versus R. Okay. So first graph shows V versus R, second graph shows E versus R. Option B is correct, not option A. Okay. This one is voltage versus distance. This is electric field versus distance. Now next, this question, another interesting question. Rimtim of VCVB. What are you trying to say? I don't understand your point. An imaginary sphere of radius r is drawn around a charge q. Okay, keeping the charge q at its center, the work required to move the test charge from point A to point B is q into 2r, 0, q into Va, q into Vb. So there are some typing mistakes, sorry for that. What is the meaning of QVA? It is Q into VA, okay, voltage at A, and it is Q into VB, okay, voltage at B. So this is, here we have VA, here we have VB, okay, clear now? 2r is the distance. Let's see who can answer this. Cassette warrior 0. Now can you answer why it is 0? Tarun is saying 0 again, except Mohan Kumar. Everyone answered it correctly. Yes, it will be 0. Now why it is 0? Can someone answer it? Just one line answer. Why it will be 0? Let's see. Why? Why 0? So this is 0, not A. Option A is not correct. Mahin. Moving charge inside, work done moving a charge inside is 0. Work required from A to B. No. Potential difference between this point. Yes, Meghna. Yes. Potential difference is 0. So first let us understand what is this. There is a charge these 2 points are at equal distance. These 2 points are at equal distance. Okay, this is also at r distance, this is also at r distance. In fact, any point on the surface, all are at a distance r. And what is the formula for electric potential? Formula for electric potential is k q by r. So basically, this circle represents an equipotential surface. This circle represents an equipotential surface. If you move a charge on an equipotential surface, suppose this is an equipotential surface, if you move a charge on an equipotential surface, because the potential is same at each and every point, the work done will be 0 always. Okay? This is an equipotential surface, potential is same, so potential difference is 0. Work done is given by charge into potential difference, charge into potential difference, because the potential difference is 0, that means work done will also be 0. V is same on both points, it is a equipotential surface. Main thing is, yes, potential is same, not only these 2 points, all points on the surface potential is same, because it is an equipotential surface, because all the points are equidistant and the potential formula is kq by r. That is the major reason. Okay, clear? We have learned something from this question. Now, the absence of an electric field, the mean velocity of free electron in a conductor at absolute temperature T is. So, electric field is absent, the mean velocity of free electrons in conductor. So, we have a conductor, no electric field is there. Okay, suppose we have a copper wire, normal copper wire. Okay, so what is the mean velocity of the electron present inside this conductor? Okay, 0, independent of t, proportional to t, proportional to t square. Okay. Rohit is saying option D. Proportional to t square. Anyone else? Yellow gaming, please answer. It is not for casual chatting. Yashwant Uday is saying option C. Now let's see. So when there is no electric field is 0. Okay. Electrons inside a conductor, they will move, but mean velocity, so electrons will move, but if an electron is moving in this direction, there will be another electron who will move in the opposite direction as well, because all the electrons are moving in random fashion. All the electrons are moving in random fashion. So, mean velocity will be, for random motion, mean velocity is always 0. Mean of random motion is always 0. If you take the RMS square, it may not be 0, but mean velocity will always be 0. So, correct answer is 0, and that is the reason. If you take a normal copper wire not connected to any of the electric field supply, you don't get electrocuted. Or if you suppose I am drinking the water from this metal bottle, okay, this is a steel bottle, I am not getting any electric shock. Why? Because it does not have any electron. Mean velocity of the electron of this bottle is 0. It has a lot of electron. If I put it into the power supply, I will get shock, but I am not getting shock right now because it is not connected to any electric field. That's why the mean velocity of the electrons are 0 and I am not getting the electric shock. So, think once or 2 seconds before answering the question. So, even though the electrons are moving, the mean velocity is 0, and that is why you are not getting any electric shock when you touch any metal objects. Okay. Now, let us see. Ohm's law is valid for the temperature of the conductor is very low, very high, constant, varying. Option C, option C, option C. Sufia is saying option A. So Ohm's law is valid only for constant temperature. Ohm's law is valid for constant temperature. At very low temperature near 0 Kelvin, there is a new property of conductor which is called superconductivity. Okay, we will study about superconductivity briefly in the 5th chapter. Okay, there is a superconductivity, mention of superconductivity is there. Okay, in dielectric material, diamagnetic material, but very high temperature metal may not be a conductor because it is already melted. So this is also not valid, and if the temperature varies, resistance vary, that means Ohm's law is also not constant, not valid. And if you see the two constant of Ohm's law, temperature and other physical conditions, that means temperature has to be constant. If the temperature and other physical conditions remains constant, then V is proportional to I, right. So that means only constant temperature is the thing that is, it is not applicable. Yes, it is not applicable at very high or low temperature. Ohm's law is not applicable for very high and very low temperature. Property of the conductor changes at very high and very low temperature. Okay. Now, with the increase of temperature, the conductivity of, so this is slightly advanced level question, but I know you can answer this question. With the increase of temperature, the conductivity of semiconductors increases and metals decreases. Metals increases, semiconductor decreases, both metals and semiconductors increases, both metal and semiconductor decreases. Let us see who can answer this. Sir, do we have 4th chapter for tomorrow's test, Tarun? If you are from North Bangalore or South Bangalore, that chapter is not there, but in some of the colleges, check with your college. Some colleges they do not have that chapter, but I can say for sure that I have checked the official syllabus from North Bangalore and South Bangalore. 4th chapter is not there, but in some district, some colleges individually included that chapter, but according to the board instruction, that chapter is not there. Okay, some colleges has completed that. They said we want to take it, and it is up to the college only. So it is there, it might be there. Which increase the temperature of the conductor. Syllabus for most of the district are same, no matter even if you are outside Bangalore or North Bangalore or South Bangalore, somewhere maybe some other districts, the syllabus is same, but some colleges personally they say we want to have this chapter because we have completed it. That freedom is given to the college, by the way. So with increase in the temperature of the conductivity, semiconductors, when you increase the temperature, okay, conductivity of semiconductor increases. Okay, so if you increase the temperature, semiconductors conductivity increases, it becomes a good conductor, whereas metals decreases, metals become a less good conductor. Okay, so option A is correct. So option A is correct for the question. Now let's go next question. Question number 24. Identical cells of each EMF E and internal resistance R are connected in series, and external resistance capital R is connected in series with the combination. The current through R is. So they are all connected in series, not parallel, right? Everything is connected in series. N identical cells, each EMF E and internal resistance R are connected in series, and external resistance capital R is connected in series with the combination. So what is the meaning of that? We have, suppose we have such n such batteries or cells, and we have an external resistance connected to this combination. Okay. So what is the current in this circuit? That is the question. Option A, sir. Question 24 saying option A. Option A, sir. What about Mike Hawk's equation in that? Is that important? Mike-Hawk equation is not important. Okay. Now let us see. So all the electric fields EMFs are connected in series. So in series, what is the equivalent equation? Equivalent relation is N into E. Okay, N into E is the total equivalent EMF. What is the equivalent resistance of the cell? Equivalent resistance is N into R. Okay, so what is the total resistance? Total resistance is the internal resistance plus external resistance. So what is the current? Current is NE divided by NR plus R. So option A is correct. Option A is correct. Okay. Yes. So all those who say option A, Rohit, no, option D is not correct. Option D is not correct. The equivalent resistance also increases in case of series combination. Parallel combination, it will be slightly different, but in series combination resistances gets added. Okay. So addition means if you add 1 plus 1 plus 1 plus 1, right. So if you add up to N, you will get N. So N times R. Now next question, if the experiment of Wheatstone bridge, the position of the cell and galvanometer are changed, then the balance point will change, remain unchanged, depend on the internal resistance of the cell and resistance of the galvanometer, none of these. So in Wheatstone bridge, if you remember, so we had a galvanometer over here and we had a cell over here. Okay. So they are saying what will happen to the balanced condition if we exchange the cell, if we connect the cell over here, suppose, and if we connect the galvanometer over here. All of you are saying option D. No, Rohit is only answering option D. So there is a good point to remind you. If you see an option none of these, 99.9% of cases this is wrong. 99.9% cases it is wrong. Unless the question is wrong, this might be a correct answer. Okay. So 99% of 0.9% cases, this is just an extra option. They could not find any other option, that's why they have added it, none of these. So if you see this option, it will be wrong. Okay. So now let me redraw this. This is the circuit. I can draw this cell like this. I can draw this cell like this, and I can draw this galvanometer like this, right. So only thing is changed is the galvanometer is rotated. Now last case also P by Q was R by S. Okay. So this case also you can find P by Q will be R by S. So the condition for balance in case of Wheatstone bridge will remain unchanged even if you change the galvanometer and cell's position. Okay, it is independent of the cell's position. Once the circuit is balanced, it will remain balanced no matter even if you change the configuration. Okay, only thing that can change the balance condition is changing the resistances itself. Even if you replace a galvanometer with a higher value resistance, or if you change the cell with a higher value of cell, the balanced condition will not change. Once the balance is achieved, it is absolute. Okay. Only by changing the resistances the balanced condition can be changed. If the resistances remain same, the balanced condition will not change. Clear? Next question. Which of the following is different from others? Volt square per ohm, ampere square ohm, volt ampere, joule per second square. Let us see who can find out what quantity is we are talking about, what quantity we are talking about. If you can find this, that will be very, very good. Volt square ohm. Volt square ohm means, if you look into the physical quantity, it is V square R. Ampere square ohm. Ampere square ohm means I square R. Okay. Volt square ohm minus 1. So, V square by R, it is I square R. Volt ampere is V into I. Joules per second square is joules per second square. Joules per second square. Okay. So, what are these quantities? So, V square by R. So, if you remember, V square by R is electric power. V square by R is electric power. I square R is also electric power. V into I is also electric power. But joule per second square is not electric power. Joule per second is electric power. Each of them has a unit, joule per second, okay, but not joule per second square. So, this is slightly tricky, that is why I am answering it for you. So, only different from the upper everything else is joules per second square, even though this might be very obvious, everything is volt and ampere, suddenly 1 joule per second square. So, even if you do not know the answer, you could have guessed the answer, but actually in reality the answer is not super simple. If they change one of the options and make it joule per second, then you will scratch your head saying that, sir, you said joule per second was wrong answer. So, that is why I always say, try to understand what is the actual meaning of this. So, if you understand the meaning, even if they change the options, they give a more proper option. For board level question, this is okay, but if the same question comes in KCET, then they will change the options, make it more difficult for you to guess. Okay, for board 99% cases this type of question will come. Now, let us see 27th question. If a current I is flowing in a straight wire parallel to positive x axis and magnetic field is there along the positive y axis, then, so now these three questions are from moving charges and magnetism. So, only those who have this, otherwise I will quickly complete it and we will move towards the numerical section very soon. Three more questions. So, electric field, current is flowing in a straight wire parallel in the positive x axis. So, this is the direction of current. Okay, magnetic field is in this direction. Okay. So, the wire will experience a force in the negative x direction, the wire will experience a force in the negative y direction, the wire experiences a force in the negative z direction, the wire experiences a force in the z direction. So, what is the expression for force acting on a wire? It is BIL sin theta. Okay, in this case theta is 90 degrees. So, 90 degrees means sin theta is 1. So, it is only BIL. Okay. So, the force is BIL. Also, it is L cross B into I. I is not a vector quantity. Okay, you have to understand that current is not a vector quantity, length is vector quantity. Length, the direction of length is taken in the direction of current. Okay, so L is in this direction, B is in this direction. So, L cross B will be out of the page. Out of the page means it is basically the Z, positive Z direction. This is positive Z direction, whereas cross is negative Z direction. If it is into the page, it will be negative. If it is out of the page, it will be positive. So, the wire will experience a force in the positive Z direction. Option D is correct. Yes. So, they told Anna Pusai's question and formula based numerical might come. Potential due to electric dipole, yes, potential due to electric dipole, Meghna, it does not come in boards. Okay, maybe in the repeat exam, that exam 2 or exam 3, it might come, but in the first exam I have not seen that question coming in last 10 years. Okay, some schools, some colleges, they sometimes give this question, but in my opinion that is not super important. If you see that question coming to your college exam, that is very much possible. You skip that, there will be options, other questions will be easy, you answer those questions. Okay, it might come very rare occasion. Okay, some teachers, they want to prove themselves that I am the superior, I want to give this question and I want to make sure that all the students are following my class properly. Or if you are if you in your college, if the students do not follow the teacher decided that I want to punish the students because they are not following my lecture, so in that case they might give it. Okay, so there are two cases. Otherwise, if the teacher is rational, if the teacher is good, definitely they generally don't give that question, right? Now let's see. A strong magnetic field is applied on a stationary electron. I don't understand your question, by the way, Sufia, no, Rim Team. Sayabu equation, I have no idea what is Sayabu equation. What is the higher possibility that we get numerical on Wheatstone bridge or we will get derivation? Sufia, this year for board exam, okay, when you are preparing for board exam, there is a 80% chance that you will get a numerical question from Wheatstone bridge and not a derivation, because derivation generally comes once in 2 years. So the derivation came last year, so there is a less chance that the derivation will come to your year. So you can expect a numerical question from Wheatstone bridge if your college do give that. But colleges generally for unit test, they generally give you an easier paper, okay, because this is the first paper that you are writing in your PU board series, right, after you came to your second PU. So generally first PU paper, in my experience, whatever I have seen, is generally easier, except obviously anomalies are there. As I told you, some teachers, they want to take revenge because you are disturbing in the class or you are not listening to the teacher. That's why teacher want to take some revenge, give you a difficult paper. Otherwise, there is a chance that Wheatstone bridge derivation will come, okay, and not the numerical one. Okay, but if you get numerical one, again other questions will come from electric charges and field or electric potential. Those are easier questions to answer than the Wheatstone bridge one, unless you have practiced a lot of Wheatstone bridge related questions or circuit theory related questions. Do not attempt that. Okay, so you have to practice at least 10 to 15 circuit theory related questions and master them and able to answer them on your own. That's why personally to my students, I generally do not recommend current electricity, even though you practice them in the exam paper. After solving the questions, you might make one small mistakes and your entire answer will be wrong. That's why personally I generally do not recommend current electricity to the students. If you are very confident, personally you should try and answer those questions. Electric charges and fields, electric potential and capacitance are relatively easier to answer because they will have simple formula based questions. Understand the formula and put the values, you will get the answer. Okay. A strong magnetic field is applied on the stationary electron, then the electron moves in the direction of the field, remains stationary, moves perpendicular to the direction of the field, moves opposite to the direction of the field. So strong magnetic field applied on an electron. So if you apply electric field, electron moves in the opposite direction. But if the electron is stationary, if it is not moving, magnetic field is 0. So the electron will be remain stationary. Why? Because magnetic field is magnetic force is given by Q V cross B, right. So this is the force that acts on a charge. But if the charge is stationary, that means V is 0. So if V is 0, the force will be 0, right. So no force will act. No force act means it will remain stationary. The frequency of rotation of the charged particle in a uniform magnetic field is independent of velocity of the particle, charge of the particle, mass of the particle, strength of the magnetic field. So let's see. So mv square by r equals to q v b. This is the formula, right. Now v square mv square by r is the centripetal force, it can also be written as m omega square r, right, because V is equal to r omega. Anyway, we will not put it over here, we will cancel the V and then we will write it as V equals to q b r by m. Now, V is r omega, put that r omega equals to q b r by m, r cancels. So, omega is equal to q b by m. So, angular frequency depends on charge, magnetic field, mass, but it does not depend on the velocity of the particle. So, option A is correct in this case. Question number 30. The radius of the circle described by the charged particle moving perpendicular to a uniform magnetic field depends on. So, radius of the charged particle. So, if you go back to the previous case, here we have eliminated the radius, but here if you go back to the same equation here and calculate the radius, you will get that radius is mv by qb. Okay, so, radius of the charged particle is given by this formula. It depends on mass, it depends on velocity, it depends on both mass and velocity. Okay, both mass and velocity, it depends, charge and magnetic field also it depends. So, both mass and velocity is the correct answer for radius, but for angular frequency it does not depend on velocity. In radius it depends on velocity. Okay, clear? Now, we are going to solve some numerical questions. First question, and if you want you can try and solve it and tell me the answers. I will also solve it. So, if you can solve it before me. Rim team, don't worry, your mothers are always like that, they will scold you, but they actually love you. Sir, from your yesterday video, today's video, can I score 30 above? Rohit, I already told you yes. Yes, Mudresh, I will upload the PDF in the, not in the website, but in the, our drive. Okay, after the lecture is over, I will upload. She will lock me in the bathroom. So, Rimtin, don't worry, take your mobile phone and study with me. Even if you are in the bathroom, that does not stop you from learning. Learning does not stop. Consider a uniform electric field E equals to 3 into 10 to the power of 3 I cap Newton per Coulomb. What is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane? Okay. What is the flux through the same square if the normal to its plane makes an angle 60 degree with the x axis? So, let us see. So, first we have an YZ plane, we have an electric field. What is the, and it is a square, sides are 10 centimeters. Electric field is given by 3 into 10 to the power of 3 I cap. Okay, so, what is the electric flux? Now, what is the formula for electric flux? First of all, you have to understand, I have solved some numericals during my lecture. So, if you have missed that, you can go and check that out, or even if you can download the PDF. These are the some different questions, different flavored questions, so that even the question paper is slightly difficult, you will be ready to answer those questions. These are not the common type of questions I have solved during my lecture. These are slightly difficult type of questions, not difficult, theory wise not difficult, but formula you may not be able to recall immediately. So, you have to be prepared for all types of questions for your exam. So, what is the formula for electric field? Electric flux. Electric flux is given by E into A. Okay. So, if you remember that electric flux is given by electric field into area, right, E dot A actually. Okay. E dot A is vector. So, Ea cos theta is general case, more generally it is Ea cos theta. Okay. But in this case, if you can see that electric field and area both are in the same direction. Okay, so, cos theta, theta is 0. So, first case option A, option A both are in the same direction. So, electric field and area are in the same direction. So, it will be E into A. E's value is given 3 into 10 to the power of 3. Now, area, this is a square, okay, of side 10 centimeter. So, what will be the area of the square? Area of the square will be 10 into 10, that is 100 centimeter square. But be careful, you will not put that 100 over here, that is the main question. You have to put that 100 into 10 to the power of minus 4 meter square. Okay, you have to convert it into meter square, that is the main question. Otherwise, there is nothing in this question, and if you forget this formula, okay, and unit will be Newton per meter square coulomb. Okay, you are dividing it by Newton meter square per coulomb. You are multiplying with area, electric field is Newton per coulomb. You are multiplying with area, so Newton meter square per coulomb. Be careful with the unit as well. This is not a KCET exam where you can skip the units. Unit has to be written correctly, otherwise marks will be deducted. So, 3 into 100 into 10 to the power of minus 1. So, it will be 30. Okay, 10 to the power of minus 1 and 1 0 cancels, you get 30 Newton meter square per coulomb. So, this is the case in the first problem. Okay. Now, second problem is same question, but in this case they said that the angle between the surface and the area is 60 degrees. So, electric field is in this direction and the area is in this direction. So, angle is 60 degree. This is part A. What will be part B? Part B is when the angle is 60 degrees. Again same formula, okay, same formula, only thing is you cannot ignore the cos theta here, you have to add cos 60 degree into this equation. Now, E dot A we have already calculated 30. E dot A we have already calculated 30. What is cos 60? Cos 60 is half. So, it will be 15 Newton meter square per coulomb. Okay. So, as you can see, the answer is 30 Newton meters per coulomb and 15 Newton meters per coulomb. Okay. Easy question, not difficult, but this type of question is very common. Dream team, be at peace with your mother. If you have any problem, you can discuss directly with her, and or if you want, just go to some counselor and take some counseling and figure it out amongst yourself. No one can help you in this matter. Okay. So, you both have to figure it out yourself. Now, next question. Yes, Gurudat, correct, good. Next, two positive charges 0.2 microcoulomb and 0.8 microcoulomb are placed at a distance 0.15 meter apart. What point on the line joining them the electric field is 0? So, this kind of question is very, very common. We have solved two such questions during my lecture. Now, this is similar question, but values are different, charges natures are different. So, we have 0.2 microcoulomb and 0.8 microcoulomb. The distance between them is 0.15 meter. Now, if you see that all the data is converted into meters, so you do not need to worry too much about it. If this is given at 15 centimeter, then you have to convert it into meters. Okay. Now, so let us see, they said at what point the electric field will be 0 between and at the line joining between the charges. Now, if you see that both charges are positive, both charges are positive. If both charges are positive, the null point, this is called null point, electric field 0 is called null point. Null point is somewhere between the charges. Null point will be somewhere between the charges and it will be closer to the small charge rather than the large charge. Okay, it will be closer to the small charge rather than the large charge. So let's say this is a distance x from point to, say this is a distance x. This charge will have an electric field in this direction, this charge will have an electric field in this direction, they will cancel each other. That is why the net electric field will be 0. So what is the electric field due to this point 2 microcoulomb? The electric field due to point 2 microcoulomb will be K Q1 by x square. K Q1 by x square. So what is K? K is 9 into 10 to the power of 9. Anyway, don't put the value of K, it will cancel. No need. K is K. What is Q1? Q1 is 0.2 microcoulomb, that is 0.2 into 10 to the power of minus 6 divided by x square. Okay. Now what is the electric field at this point due to 0.8? Electric field due to 0.8 will be K Q2 by 0.15 minus x whole square. Why so? Because total distance is 0.15 meter, this much distance is x, so this distance will be 0.15 minus x, right? This is the most difficult part of this problem is figuring out this. Okay. So if you figure this out, these two equations, then the problem is very simple. So K into 0.8 into 10 to the power of minus 6 divided by 0.15 minus x whole square. Okay. So this is the two electric fields. Now if this there is no electric field at this point, then magnitude wise both of them has to be the same value. Both of them should have the same value, right? Magnitude wise, direction wise opposite, magnitude wise same. Okay. So now let's put the values. K into 0.2 into 10 to the power of minus 6 divided by x square equals to K into 0.8 into 10 to the power of minus 6 divided by 1.15 minus x whole square. Okay. So K cancels, 10 to the power of minus 6 cancels, even the decimals also got cancelled. So we get 2 by x square equals to 8 by 0.15 minus x whole square. So you can also cancel this, you get what you get? You get 0.15 minus x whole square by x square equals to 4. Okay. So left hand side you have a square, right hand side you have 4. So you can write this as square 2 square, or you can write this as 0.15 minus x by x equals to 2. Okay. You have taken square root on both sides, so squares get cancelled and you get this value. Now simplify this, you get 0.15 minus x equals to 2x, okay, or 0.15 equals to 3x, 2x plus x, or x equals to 0.15 divided by 3, that is 0.5, not 0.5. If you are saying 0.5, you are wrong. It will be 0.05 meter. So from 0.2 microcoulomb, the distance is 0.05 meter. From 0.8 meter, from 0.8 microcoulomb, it will be 0.15 minus 0.05, that is 0.1 meter. So any answer you write, it will be considered to be correct. 0.05 meter from the 0.2 microcoulomb charge. Okay. Now next question. Capacitance of a parallel plate air capacitor is 1 nanofarad and the plates are separated by a 2 millimeter. Find the area of each plate of the capacitor. Okay, capacitance is given 1 nanofarad. Okay, separated by a distance of 2 millimeter. So, distance is given by 2 millimeter. Find the area of the plates. Okay, it is a air capacitor. So, what is 1 nanofarad? Nanofarad means 1 into 10 to the power of minus. Now, I will not solve the final answer because it requires a little bit of calculator. Okay, I will tell you what to do and you will calculate it. 2 millimeter is 10 to the power of minus 3 meter. This is farad. You have to calculate the area. How to calculate that? C is equal to epsilon naught A by D. C is equal to epsilon naught A by D. So, area equals to C into D by epsilon naught. So, if you put the values, you will get the answer. C is 1 into 10 to the power of minus 9. D is 2 into 10 to the power of minus 3 and epsilon naught is 8.85 into 10 to the power of minus 12. Okay, it is 1 by it is epsilon naught, not 4 pi epsilon naught. So, be careful. Okay. So, this will be the value and now you have to cancel. So, 10 to the power of minus 9 and minus 3 they get cancelled with 10 to the power of minus 12, right. So, you get this as 2 divided by 8.85. Now, you calculate what is the value, area. What is the area? Sufia, yes, you can access this lecture. 2 divided by 8.85. It will be, yes, you are correct. Those who, someone who was typing 0.22, yes, you are correct. It will be 0.226 meter square. Unit is very, very important because you are calculating area. It will be meter square. Okay, 0.22. Yes, Tarun, 0.226 meter square, right? Now, next question. Two charges of 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing the charges 2 centimeter closer. So, we have charges 10 and 5 separated by a distance 12 centimeter. Okay. Now, if you want to bring them 2 centimeter closer, that means the final distance between them will be 10 centimeter. So, initially they are 12 centimeter apart, final distance is 10 centimeter. You have to calculate what is the work done. If you keep this charge fixed, suppose you bring this charge closer, that is the work done. So, how to do that? For that you have to calculate the initial potential energy and final potential energy and find the difference between them. So, what is the initial potential energy? Initial potential energy is K Q1 Q2 by the distance square. K Q1 Q2 by the distance square. So, what is K? K is 9 into 10 to the power of minus 9. Q1 is 10 microcoulomb, that is 10 into 10 to the power of minus 6, and Q2 is 5 microcoulomb, that is 5 into 10 to the power of minus 6. There is a sort of mistake. This will be 10 to the power of 9. And what is the distance? Distance initially was 12 centimeter. So, 12 centimeter is 12 into 10 to the power of minus 2 whole square. Okay. Always convert centimeter to meter by multiplying 10 to the power of minus 2 to convert it into meter. Always do that. That will be very, very mistake free, I will say. Now, what is this? 10 to the power of minus 9 minus 6 minus 6 minus 12 plus 9, it will be minus 3. So, 440 into 10 to the power of minus 3 divided by 144 into 10 to the power of minus 4. So, it will be 450 into 10 divided by 144. Okay, you can cancel some of them, I guess. $150 48 50 by 16. So, you will get this as 500 divided by 16. Okay. Even you can cancel it little bit more, but I will do it later on. Okay. So, this is the initial potential energy. What is the final potential energy? Same formula. Only thing that will change is the distance. Now, distance is 10 centimeter. So, let us put that value 9 into 10 to the power of 9 into 10 into 10 to the power of minus 6. Into 10 to the power of minus 6 into 5 into 10 to the power of minus 6 divided by r square is now 10 centimeter, that is 10 into 10 to the power of minus 2 whole square. Okay. So, if you simplify, everything will be remain same, the top part will remain same, 450 into 10 to the power of minus 3 divided by, in the division the value will change, it will be 10 to the power of minus 1 minus 2. So, it will be 45. Okay. So, 45 is the final potential energy, 500 by 16 is the initial potential energy. So, what is the work done? So, work done is basically given by the change in the potential energy, which will be final minus initial. So, you have to do this calculation using your calculator and calculate it, it will come out to be 0.75 joules, 0.75 joules. Manoj Mannu, hi Manoj, I have done a first PU video as well, you can go and check that out, not the live, but we have done a complete revision video in the first PU section as well, where I have discussed all the 4 chapters. They are all important questions and their explanations and answers, right, including numericals. Please go and check that out. Sufia is saying minus 41.875. Let us see. $500 by 16 is 31.25. So, 45 by minus 31.25 will be 13.75. Sorry, that is a mistake. It will be 13.75. Not 0.75. So, it will be 13.75. Okay. Sufia, check your calculations. 500 by 16 is 31.25, and then if you subtract it from 45, you will get 13.75, not minus. Okay. Gurudatta, check your calculation once. Which calculation, which value you got? Let me check it once more. Wait. So 9 into 5 is 45. 45 is 10 into 450. So it will be 450 10 to the power of 9 minus 6 it will be minus 12 plus 9 minus 3 is there. 12 square is 144 divided by 10 to the power of minus 4. So what I have done is here, okay, let me simplify this. Okay, let me simplify this. Let's see. I am sure up to this point there is no mistake, right. So 450 into 10 to the power of minus 3 divided by 12 centimeter into 10 to the power minus 2, that is 144 into 10 to the power minus 4. So it will be this minus 4 will go up and it will become okay. This was the value, this is the value. Now what we will do, we will take this as common, 450 into 10 divided by 144. This is U1, and this one I can write this as 450 4500 divided by 100. Okay. Now let us see. So this is also 4500 divided by 144. Okay. Now what is the difference? Work done is basically difference in potential energy U2 minus U1, that is 4500 common 1 by 100 minus 1 by 144. Okay. So difference, this is common, right. So it will be 4500 into 144 minus 100 divided by 1400. Okay. So it will be I am running out of space. It will be 4500 into 44 divided by 1400. So 00 cancels. So 45 into 44 divided by 14. Okay, it is not 0.75. It is not coming 0.75. 45 into 44 divided by 14. Sorry, divided by 144. Right, it was 144. So 144, it will be 13.75. Yes, 13.7. Gurudat, if you get the value as 0.75, please check. It is not for 450, Sufia. It is 450 into 10. There was 110 because there was 10 to the power of minus 4 over here, 10 to the power of minus 3 over here. So 10 will go up. So it will be 450 into 10 by 144, not 450 by 144. Okay. See here, do not try to use the formula, try to use the step by step calculations. Okay, K Q1 Q2 by R square. Okay, if you find any mistakes in this calculation, please tell me. Okay. initial distance was 12 centimeter. So, you have to put the charge values and everything step by step, check the calculation. Also, I will check it myself and I will let you know in case there is a difference in the answer. Okay, I will provide it in terms of PDF. Okay. Okay, 13.75 I got. I will check it once more, and in case I find some discrepancies, I will tell you later again. Okay, I will correct it and I will make sure that you get the correct PDF. Now let's solve the last. I think this is the last. This is the last question. Okay, two capacitors of capacitances 2 picofarad and 4 picofarad are connected in parallel across 10 volt supply. What is the total capacitance of the combination? Determine the charge on each capacitor. So, this is first part is easy, second part is slightly long. I will not say this is a difficult question. This type of questions are very common. So, two capacitors 2 picofarad and 4 picofarad, they are connected in a 100 volt supply. Okay, so this is a 100 volt supply, 2 picofarad and 4 picofarad. Okay, what is the total capacitance of the combination? What is the total combination? They are connected in series. No, sorry, they are connected in parallel. My mistake. So, parallel combination is easy, 2 and 4 connected in parallel. So, total capacitance is basically sum of the capacitances, parallel combination gets added. So, 6 picofarad is the total capacitance, right. Now, determine the charge on each capacitors. So, charge will be distributed among the capacitors Q1 and Q2, right. Now, you do not need to do anything with this 6 picofarad. Okay, this is just equivalent capacitance, first part is done. Now, you have to understand that because they are connected in parallel combination charge varies, but voltage remains same. In series combination charge remains same, voltage is different, right. So, voltage is same for both the capacitors, that is equals to 100 volt. So, suppose the first capacitor has charge Q1 and the capacitance is 2. So, charge Q1 into 2 picofarad, pico means 10 to the power of minus 12, that Q is equal to C into V. Q equals to C into V. What is V? V is 100 volt, which is given in the question. So, it will be 2 into 10 to the power of minus 10 coulomb, okay, or 0.2 nano coulomb. Okay, how did I do that? 0.2 into 10 to the power of minus 9 coulomb. So, 10 to the power of minus 9 means nano. So, it becomes 0.2 nano coulomb. What will be Q2? Q2 will be 4 picofarad. 4 picofarad means 4 into 10 to the power of minus 12 into 100. So, that will be 0.4 nano coulomb. Similarly, okay, you do not need to do the mathematics again and again, and this is very easy question, and this is one of the board's previous years sample paper question. So, as you can see, calculating the equivalent circuit you get 1 mark, for calculating these two you get 2 marks, 5 marks, okay, and circuit diagram is compulsory in this case. So, circuit diagram you have to draw, right. So, with this I will like to close this live session. It is a long, not super long, but again 2 hours long live session. So, and if you have any doubts, any questions, please post in the Harish Teja. My name is Shomik sir, okay, you can call me Shomik sir, right. Every live videos that I do, I always Guru Dutt. Okay, let me see. Yes, correct. So correct. Yes, you are correct. V will be proportional to R, not R square. Sorry, my mistake. Yes. So let me correct that. It will be R, not R squares. Yes. Thank you, Guru Dutt. So this will be 12 into 10 to the power of minus 2. So it will be 1 0 minus 2 minus 2. So 45 by 12, and here we will have 45 by 10. Okay, 45 by 12 and 45 by 10. So work done will be difference in potential energy, that is 45 by 10 minus 45 by 12. So it will be 45, 12 minus 10 by 120, and I hope if you simplify this, you will get this as 0.75. Yes. So 13.75 is not correct. Yes. Okay. So please don't forget to mention that in the comment. So do I have watch you provided lecture for more numericals? Rida, if you can do that, that is very good. You can watch that in 2x speed, no issues if you can understand. Okay, I generally take the classes little slower, so 2x speed, if you can watch it, then it will be very helpful for you. Otherwise, you at least you can, what you can do, you can check the solution that is provided in the Google Drive, and then if you don't understand it, you can go and check only the numerical portions you can check. Okay, because numerical portions is going to be slightly difficult for you, because most of you, I know, do not practice numericals very often, right? Sophia sir, 5 numerical are enough. 5 numericals along with the numericals I have done in the lecture, I think another 5 numericals I have done. The values will not be the same, concept will be the same, formulas will be the same. Okay, so if you, like I did a mistake over here, so don't repeat the mistake that I did. So potential energy is k q1 q2 by r, not r square. Okay, so don't make those mistakes and you will be fine, right, Sophia? So don't make mistakes, try to avoid mistakes, and practice a few more numericals. If you want, you can practice from your NCERT textbook. Okay, in the end of the textbook there are few numericals also. I covered a few of the important numericals in my lecture. The two or three of them are from your NCERT textbook. You can check that out again. Otherwise, these are the numericals which is mainly important for formulas and concept. Okay, so try to understand that, and please do let me know, sir, any tips for the test. Rida, I just request you, be patient, be calm, don't be in a hurry. Okay, you will have a lot of time and utilize the entire 1.5 hour that you will get. Okay, and if you are thinking that okay, maybe I will make mistakes in the MCQs or in the fill in the blanks, leave them. Try to answer 2 marker, 3 marker, 5 marker questions, which will be almost common. Okay, if you see my quick revision videos, and questions will be 90% questions will be common. There will be some questions uncommon, but that questions you can skip. Why? Because there will be options to you. You can skip 1 or 2 questions, so no worries about that. There will be extra questions. You can skip the difficult questions, easy questions you write, and then once you are done with everything, you try MCQs and lastly numericals. Okay, don't leave any questions unattended. Try to answer all the questions. That is the tip, and stay calm. Calmness is important. Sir, I am new for this class. Can you say what is this? Harish Teja, I discussed 30 MCQs and numerical questions. This is for your unit test 1 preparation, okay, for physics. I have discussed 30 MCQs and numericals today. There was one more lecture I did in the past, last week. Okay, you can go check that out as well, where I have discussed all the important questions, 2 marker, 3 marker, 5 marker derivations as well. So I hope important derivatives, for example, from electric charges and field chapter, single line charge and spherical shell, okay, for point charge, electric potential due to a point charge. It is the most repeated question in PU history, electric potential due to a point charge, okay. Then cells in series, cells in parallel, and Wheatstone bridge. These are the major derivations. At least for 2 derivations you have to answer. So at least practice few of them, so that you have some options in case some uncommon derivation comes. Then you have some options. For example, last year PU board, I suggested the whatever derivations I have suggested, all the derivations are common, okay. 4 derivations were common, only 1 was uncommon, 3 you have to answer. So that was the level. So you have to understand that there may be some cases 1 or 2 derivations may not be common, but you prepare yourself so that you can write the 2 derivations that will be common, right. I hope that's clear your doubt, Rida. So with this I will like to end this session. It is 12:30 and Prime Minister is in nearby, so maybe the roads will be closed and all. So I am sorry for that, but anyway, I enjoyed the session today. I hope you also enjoyed. If you have any doubts, any questions, please mention in the comment. And also once your exam is over, please do let me know how was your exam. I will be eagerly waiting for your feedback. And don't miss out other lecturers as well. They will also do live from tomorrow onwards. That chemistry and I think chemistry and biology is tomorrow. So don't miss that out. After your exams are over, come home, refresh, fresh up, and then attend the live lectures by the respective teachers. Okay. With this note, I would like to end this session. Thank you and all the best for your unit test.